In the last couple of videos, we've spent our time inserting documents into the database. Right here as an example, this code inserts 3 documents into the tasks collection. Each task has a description and completed field. Now, when we viewed that data over in Robo3T, we saw all of our descriptions and all of our completed values, along with one additional field which we did not specify, _ID. Now, I briefly mentioned that this field is automatically created by MongoDB, and it stores a unique identifier for each document you insert into the database. In this video, before we go any further, I want to take a little time to talk about the value inside. We're going to talk about what object IDs are, why they're used, and how they're going to play an important role in MongoDB. Now, the value we're seeing here for the ID is much different than what we would see in a traditional SQL database, and this is by design. So in an SQL database like MySQL, the server generates the ID for new records, and it follows that auto-incrementing integer pattern, where the first record has the ID of 1, the second 2, 3, 4, and so on. With MongoDB, the IDs are known as GUIDs, which stands for Globally Unique Identifiers, and these are a bit different. They're designed to be unique using an algorithm without needing the server to determine what the next ID value is. Switching from auto-incrementing integers over to globally unique identifiers allowed MongoDB to achieve one of its main goals, which is the ability to scale well in a distributed system. So we have multiple database servers running instead of just one, allowing us to handle heavy traffic where we have a lot of queries coming in. With MongoDB and GUIDs, there's no chance of an ID collision across those database servers. With an auto-incrementing integer, it's definitely possible that we could have a user with an ID of 1 in one database server and a user with an ID of 1 in another database server, and we could eventually run into an issue where those IDs conflict. With MongoDB, we don't run into that problem. Another great advantage is that we can actually generate the IDs for our documents before we ever insert them into the database. So our server doesn't need to be the one who generates the ID. We can actually use that MongoDB library to generate object IDs of our own. And that's where I want to start. We're going to generate some object IDs using Node.js, then we'll dissect them and explore exactly what they're made of. Let's switch over to Visual Studio Code and get this process started. The first thing I'm going to do is comment out our call to insert many down below, where we insert into the tasks collection. The reason I'm commenting this out is that I don't want to insert these same tasks again when the file runs. For the moment, we're not actually going to change the database in any way. What we're going to do is grab something else off of MongoDB that allows us to work with object IDs. So down below where we set up Mongo Client, I can create a new constant for capital O object, capital I, capital D. And we're going to get the value for that off of a property on MongoDB with the exact same name, object ID. Now you'll notice here that we're grabbing a lot of individual things off of MongoDB, and we're storing those in individual variables. This is a great use case for destructuring, which we covered earlier in the class. So as an example, we could achieve the exact same thing with the following code. I'm going to comment out this code so we can leave it in place. And what we're going to do is create a constant. Now, we know we get an object back from require, MongoDB, and we know it's an object because we've been accessing properties on it. So right here, we'll just destructure that. I'm going to grab Mongo Client, and I'm also going to grab object ID. Now, where am I going to grab them from? An object, that's how destructuring works. And I have the object as the return value for calling require with MongoDB. Perfect. So this is just a shorthand for grabbing things off of MongoDB. Now, the old code is still going to work exactly the same. MongoClient.connect is still going to work as expected, but now we're going to be able to generate our own IDs right here from the file. And to do that, let's start by creating a variable to store the ID. Then we're going to use object ID, which we just grabbed. Now, that's a constructor function, so we use it with the new keyword. That is new. Object, capital I, capital D, and we call it providing no arguments. this is a function that's going to generate a new ID for us. Now, the new keyword is technically optional because the MongoDB library has a little defensive programming built in to add it if you don't, but it's in general a good idea to add it in ourselves. Down below, we can now do something with this ID, and all I'm going to do is dump it to the console. So for me, console.log, printing ID to the terminal. Now that we have this in place, let's go ahead and test things out. Down below, we are running commands from the task manager directory, and we're just going to run this file once again. Right here, node space mongodb.js, and when I run it, what do I get? I get a brand new object ID showing up. Now you'll notice that once again, the program is hanging because we do have that open connection. We can always use Control-C to shut that down. Now let's talk about the ID value itself. What we have here is not just one long, randomly generated series of characters. There's actually a few different pieces of information inside of here. Embedded in there, for example, is a timestamp, and we can learn more by heading over to the browser. Now, you don't need to pull up the following website, since we're only going to use it for a brief moment as a visualization to see what I'm talking about. I'm going to Google MongoDB object ID, and we're looking for their object ID documentation on the reference site. So right here, that is the reference documentation as opposed to the API docs. And when we pull that up, it's going to give us a breakdown of what exactly an object ID is made of. Right here, an object ID is a 12-byte value, which consists of the following. The first 4 bytes of the object ID represent the number of seconds since the Unix epoch. So that is a point in time which has been decided upon, and that is midnight, January 1st of 1970. So embedded inside of all of your object IDs is actually a timestamp which knows when the particular object ID was created, which can be of great value in the long term as your data set grows. Next up, after the first 4 bytes, we have the following 5 bytes. These are a randomly generated value, and the last 3 bytes are a counter starting with a random value. Now, when we put all of this together, we have a very complex algorithm that allows us to generate a globally unique ID without needing a central authority to tell us what the next ID is. And we just saw that since we generated an object ID inside of our Node.js code. Now I'm going to close down this tab and we're going to head back over to the API documentation. Down below under O for object ID, there is indeed an entry. And if we click that, we can explore some of the methods available to us. And the only one we're really going to use, and we're only going to use it for this example, is getTimestamp. GetTimestamp gets the timestamp that's stored inside of the first 4 bytes for that object ID, and we can go ahead and use this method to actually print those out. So right here, we're going to add another console.log line down below, console.log id.getTimestamp, and we are going to call that as a function, which it is, and the documentation says it doesn't need to take any arguments, and we're going to get our timestamp back. So what I'm going to do is save the program and rerun it to view the timestamp. Right here, I'll shut things down, rerun the script, and what do I get? I get a timestamp. Right here, I can see the current point in time, which is indeed accurate, and right here, I have the exact hour, minute, and second, and if I shut the script down and I rerun it, you can see it's updated a little bit. We went from the 49th minute to still the 49th minute, but we were at 34 seconds into the minute earlier, and the second time I ran it, we were at 47 seconds. So as we generate new IDs either on our own or as MongoDB generates them for us, a timestamp is indeed embedded right inside of there, allowing you to know when it was created. Now let's go ahead and use our generated object ID as the actual ID for a new document we insert. So down below, I have the first insert one call we explored a couple of videos ago. I'm going to take that entire call and uncomment it, and we'll just change up the data a little bit. Right here, I have the name. I'll change that over to Vikram, and I'll change the age as well to something like 26. Now, alongside of the 2 fields, we're also going to specify _ID, and we have to provide, if we're choosing to set _ID, an object ID. We already have one created and stored in the ID variable, So I can go ahead and reference that right here. Now let's go ahead and save the program to rerun things. When we rerun it, we're going to see our new ID printed to the terminal, and then we're going to be able to compare that with the ID we see over in Robo3T when we view our document. So right here, I'll shut it down, I'll start it up again, and we have our data showing up. So we have the actual data that came back from the server as the result of the operation, and it matches up perfectly with the ID we have right here. If we head over to Robo3T, we'll be able to see the exact same value in that user's collection. I'm going to refresh the page using Command R or Control R, and right here, we do indeed have the exact same ID that we had just generated over inside of the terminal. Now, there's just one more thing I want to talk about related to object IDs before we wrap up. For the moment, I'm going to remove that ID property, and I'm going to comment out this example once again. I just set that up to show you that you can provide your own object ID if you want to. Now, for our purposes, we're not going to do that because it's just extra code. We can have MongoDB automatically generate it for us, and in most cases, we don't need to know the object ID value before the document is inserted. But if you needed to, you could. Right here, the last thing we're going to talk about is how object IDs are stored, because that plays an important role as well. In the terminal, when we see an object ID, we just see the series of characters that make it up. So right here, we have an ID that starts with 5C and ends with 7-1. Now over in Robo3T, we have the exact same ID that starts with 5C and ends with 7-1 for the new document we just created, but there's also some extra stuff on each end. What we have here is a function call where this string is being provided as the first and only argument. So this is a visualization, making it easier to see the object ID value because IDs are indeed binary data. Now, the reason they're using binary data over a traditional string has to do with the size of each. By using binary instead of a string, they're able to cut the size of an object ID in half, and we can quickly prove that just to explain exactly why this is the way they chose to go about things. So over inside of our code, we have this ID variable that actually has an ID property on it. This contains the raw binary information. What I'm going to do is take a quick moment to save the file and rerun it just so we can see that. I'll shut things down, start them up again, and right here we have our buffer with the binary data inside. Now we can check the length of this by using id.id.length, and right here we're going to see, if we rerun the program, that the length is indeed 12, which matches up exactly with what we explored in the documentation before. We have that 12-byte value where we have the timestamp, the random value, and we have the incrementing value at the end. Now, if we were to convert that from binary into a string, it would double in size. So right here, we can do just that using a method available on object IDs. If we head over to the API docs for one final time, we already explored getTimestamp. To do what we want to do, we're going to use toHexString, which is going to convert it over to its string representation. So right here, to get that done, we'll use console.log id.toHexString. We're going to call that as a function. That's going to return the string representation, and all we're going to do is check its length. So right here, we're printing the original object ID length, then the length of the string representation. I'm going to save the program. I'm going to shut things down. I'm going to restart it, and right here, we can see that the original representation was just 12, while the string representation was double in size at 24. So this is the reason we are seeing object ID all around. It is just a way to visualize easier for humans what exactly is happening. So here it's giving us the representation as a string, but it's wrapping it in this object ID call to let us know that it's not actually a string. It's what comes back from this function call, which would be binary data. But to save us a lot of time and to save us from some really long lines in our table, all of that is abstracted away from us, the end user of MongoDB. Now you might be wondering, why did we just spend so much time learning about IDs? We were just getting into the fun stuff. And the reason is that we need to know about object IDs in order to be able to fetch our documents by ID, which is something we're going to do in the very next video. So that's it for this one. There's no challenge here. I just wanted to give you a little background on what exactly is going on with IDs in MongoDB. In the next video, we'll get back to exploring the database, and you'll learn how to fetch your documents out of it. Let's go ahead and jump right in.